So part 3, memory management schemes. There are 4 types of memory management schemes. Number 1, paging. Number 2, segmentation. Number 3, demand paging. And number 4, swapping. We will stop on each one, and then we will cover description, the management, advantages and disadvantages. So let's start with paging. Paging divides the physical memory into fixed size blocks called frames and the logical memory into blocks of the same size called pages. When a process is executed, its pages are loaded into any available memory frames. The management. It uses a page table to keep track of the mapping between the logical pages and physical frames. Advantages. It eliminates external fragmentation, simplifies memory allocation by using fixed size units. Disadvantages. It may cause internal fragmentation, and it may require additional memory for storing page tables. So this was for the paging. Segmentation. It divides the memory into variable size segments based on the logical division of a program, such as functions and data. Each segment is a different size and can grow or shrink dynamically. The management uses segment table to keep track of each segment's base, address, and limit. What are the advantages? It facilitates modularity and protection by logically dividing a program. It can handle growing data structures better than paging. What are the disadvantages? It can lead to external fragmentation and more complex memory management compared to paging. So what is demand paging? It's a type of paging where pages are only loaded into memory when they are needed, on demand, for example. If a required page is not in memory, a page fault occurs and the operating system loads the page from a disk. The management. It maintains a page table, uses a page replacement algorithm to manage memory. The advantages. Demand paging reduces memory usage by loading only the necessary pages, and it can run processes larger than physical memory. The disadvantages. Page faults can cause significant performance overhead, and it requires efficient page replacement algorithms to minimize faults. So damages can be huge. And finally, we have swapping. The swapping temporarily moves entire process in and out of main memory to a backing store to free up memory for other processes. In terms of management, the operating system manages the swapping of processes by maintaining a process queue and managing memory allocation. The advantages. The swapping allows for better utilization of memory by freeing up space for active processes. And it facilitates multitasking by enabling multiple processes to share the same physical memory. Disadvantages. Swapping can be time-consuming and cause performance degradation due to the overhead of transferring data between memory and disk. It can also lead to excessive paging, known as trashing, if not managed properly. So this was for swapping. Here we have the references. Basically, today we tried to cover the virtual memory, cache memory, and memory management schemes. Under each of these 3 parts, we tried to give definition, the importance of these types of memories, and also advantages and disadvantages. Hope you enjoyed our tutorial and learned basic understanding information about these memory types, and you can explain yourself or you can give more explanation when you are asked about this. So do not stop learning. Let's learn together and see you in our next tutorial. Please watch again, like our videos, and don't forget to subscribe. Thank you. See you next time.